Alright, so here's my fourth video on evaluating integrals using trigonometric substitution. Alright, so if we have integrals involving square root of a squared minus u squared, we'll let u equal a sine theta. Okay, a is a constant, u is our variable. And integrals involving square root of a squared plus u squared, we'll let u equal a tangent theta. And then integrals involving square root of u squared minus a squared, we'll let u equal a secant theta. Alright, so let's take a look at our example. Okay. Alright, so here we have the integral of square root of x squared minus 3 over x dx, and we're evaluating it from square root of 3 to 2. Okay. Alright, so let's see which one we have. This is x squared minus 3, and so, well, you can see here that's square root of u squared minus a squared. Okay, and notice in our problem we have the square root of x squared minus 3. So see, there's our u squared or x squared in our problem, and then a squared is 3. So that means a would be what? Square root of 3. Okay. Alright, so let's go back and also you see we'll let u, or in this case x, equal a secant theta. Okay. Alright, so we're gonna let x equal a, and in this case a is square root of 3, because see the 3 here is a squared, so that's square root of 3 times secant theta, and so dx is square root of 3. Remember the derivative of secant, that's secant theta tangent theta d theta. Alright, so let's see what we have. We have the integral, we're going from square root of 3 to 2, square root x squared minus 3 over x dx. Okay. Alright, so this is going to give us, let's plug everything in, x, okay, we're going to plug in for x, square root of 3 secant theta. So that's going to be square root of 3 secant theta, and all that's squared, minus 3, and that's all over x. Well, what's x? That's square root of 3 secant theta. Okay, and then dx, okay, so we've got to plug in for dx also, and so that's times, and I'm going to go ahead and extend this on out and put this in the numerator. That's square root of 3, and square root of 3 secant theta tangent theta, okay, d theta. Alright, now if you've watched my other videos, you notice we after we simplified all this and we integrated it, we got an answer in terms of a trig function, and then we had to draw our triangle and get everything back in terms of x. Well, here we have limits on our integral, so we really don't need to put everything back in terms of x as long as we rewrite our limits. Okay, so remember, now we're in terms of theta, so I need to rewrite these limits, and you might be familiar with this from when you did integrals using u substitution. Okay, alright, so we need to get our limits in terms of theta. Alright, well, remember these limits here are x values. Okay, well, So let's start out, let's convert this one. So we have square root of 3, and remember that's an x value. So I can come up here and use this. Okay, see, I can take the square root of 3 and plug it in for x, and then what happens? I can solve for theta. Okay, so let's go ahead and do that. So I have square root of 3 equals square root of 3 secant theta, which means that secant theta equals 1. See, if I divide both sides by square root of 3. Alright, so now let's evaluate. Let's figure out what theta is. Well, I've got secant theta equals 1. Well, I don't know what secant theta equals 1. I don't know about secant theta, but I do know about cosine theta. So if I rewrite this as cosine theta equals, now remember, cosine is the reciprocal of secant. So if I take the reciprocal of 1, well, I just get 1 back. And so this tells me here that theta, okay, well, the cosine of what is 1? Well, that's the cosine of 0. Okay, so I get theta is 0. Now let's convert the 2. So now I'm going to take the 2 and plug it in for x. So I get 2 equals square root of 3 secant theta, which tells me that secant theta is equal to 2 over the square root of 3. Okay, and once again, let's rewrite this in terms of cosine. So that tells me that cosine theta is equal to the reciprocal of this, square root of 3 over 2, which means theta is, well, the cosine of what is square root of 3 over 2? Well, that's the cosine of 30 degrees, or what, pi over 6. Okay, so my limits are 0 to pi over 6. Okay, and like I said, you don't have to do this. I mean, you can simplify this, integrate it, and then do like we did in the previous 3 videos, and put everything back in terms of x. Okay, and then you can use these limits. But I think it's just easier just to convert the limits and leave everything as trig functions. Okay, alright, so let's go ahead and just write this down again. Okay, so I have 0 to pi over 6 square root of, now let's see what we've got here. Let's go ahead and just square that. So that's going to be what? 3 secant squared theta minus 3, okay, times square root of 3 secant theta tangent theta d theta over square root of 3 secant theta. Okay, alright. So this is going to give us 0 to pi over 6. Okay, now look at this. You see how the this square root of 3 and this square root of 3 cancel. Okay, we could cancel that, and we can also cancel the secant thetas here. Okay, we can cancel the secant theta. Alright, so let's see what we've got. Secant theta and secant theta cancel. And so that's going to leave us with this. And look at this. We can factor out a 3. So let's factor a 3 out. So that's going to be square root of 3 times secant squared theta minus 1. Okay, times, and see, these canceled, so I'm just left with tangent theta d theta, and since all those canceled, that would just be over 1, so I'll just leave that like it is. Okay, looks kind of funny up there towards the top of the integral. Alright, so let's see what we've got. Alright, so let's separate this. I've got 0 to pi over 6, and that's going to be square root of 3 times the square root. Remember, you can separate the radicals, and I'll just go ahead and write this again. Oop. That's going to be square root secant squared theta minus 1 times tangent theta d theta. Okay. And so now let's bring this radical out. So that's square root of 3, 0 to pi over 6, and then let's look at this, secant squared theta minus 1. Well, if you recall, 1 plus tangent squared theta is equal to secant squared theta. So if I move the 1 over, I get tangent squared theta equals secant squared theta minus 1. Okay. Alright, so let's replace secant squared theta minus 1 with tangent squared theta. So that's tangent squared theta times tangent theta d theta. Let me get this out of the way. Alright, so we have square root of 3 from 0 to pi over 6. Now the square root of tangent squared is tangent theta, so that's tangent theta times tangent theta d theta, which is the square root of 3 from 0 to pi over 6 of tangent squared theta d theta. Alright, now let's look at this, the integral of tangent squared theta. Well, we don't have a special formula for tangent squared theta, but let's see. If we take tangent squared, okay, and remember the identity I had up here, 1 plus tangent squared theta equals secant squared theta. So tangent squared theta equals secant squared theta minus 1. Well, if I convert this to secant squared theta minus 1, I know the antiderivative of secant squared, that's tangent. And then I also know the antiderivative of 1, that would just be theta. So let's convert this into secant squared theta minus 1. So this is going to be square root of 3 from 0 to pi over 6 of secant squared theta minus 1 d theta. Okay, and now if we integrate, that's going to be square root of 3. I'll write the 3 a little better. That's going to be the square root of 3. And then when I integrate, I get tangent theta minus theta, and I'm evaluating that from 0 to pi over 6. Okay, so now let's plug this in. So I get square root of 3 times tangent of pi over 6 minus 0 minus, and then plug the 0 in, tangent 0 minus 0. And I'm sorry, I messed up. I plug the pi over 6 in for theta, and I get tangent pi over 6 minus, and then I have to plug the pi over 6 in for theta, so that's minus pi over 6. Okay, I guess I was looking at the 0 when I wrote it down. Alright, now this is going to give us the square root of 3 times, now look at this, tangent of 0 is 0, and 0 minus 0 is 0, so all that is just 0, so we don't need that anymore. Alright, well what about this, tangent of pi over 6? Well, that's the same, that's tangent of 30 degrees, which is what, square root of 3 over 3 minus pi over 6. And then if I distribute that, square root of 3 times square root of 3, that's just going to leave me with 3 over 3 minus square root of 3 times pi over 6, which gives me 1 minus square root of 3 pi over 6. And there's our answer. And if you want to punch it into your calculator, you'll get 0.0931. Okay. Alright, so I know this video was kind of long, but I hope it helped. Like I said, I know I didn't, in this video, I didn't put it back in terms of x because we didn't need to. Okay, we were evaluating the integral. We had limits on the integral. So what I did is I converted my limits from x values to theta for values of theta, okay, by doing this right here. Okay, if you want to check out some videos where after I evaluate it and then put it back in terms of x, you can check out my first 3 videos because there's no limits on the integrals there. So you can check those out if you want to see that. But I hope it helped. If you like them, watch my other videos and you can subscribe. Alright, thanks.